Who is in your league? Let's take a $80 buy-in.
Okay, guys, page 19.
It was $100 buy-in.
12 people.
So this is a very very specific type of problem, but the reason that I want to put this on the test is because this is a very common problem to see on the AP exam. They love to ask these types of questions. So I just want to show you what this looks like. So it says find constants to make the piecewise function continuous and differentiable. Sometimes they may not even use the word continuous. They may just use the word differentiable. But it's nice to think in terms of continuous and differentiable because both those parts will produce the equations that you need to get to the answer. So we have two piecewise functions. Okay, what that means is that at one, it may or may not connect depending on what these expressions are. But we're told that not only are they connected, meaning that they're going to share the same y value at x equals 1. So we can say that they must share the same y value at x equals 1, because that's the only place where the graph may be disconnected, right? These are both going to be nice polynomials or linear equations where normally there wouldn't be any breaks, but because you're breaking them off at 1, if they don't connect, then we're going to experience a break. What does differentiable mean? What do we say? It has to do with so differentiable means smooth curve. And it has to do with slope. So that means if it's a smooth curve, that means both my expressions, not only are they connected, they must connect in a way where it's a smooth transition. That the end of this graph is going to share the same slope at the beginning of the other graph, so that there's not going to be any sharp turns. So that means they must share the same slope at x equals 1. So those are the key points there. We have to create a scenario where the two graphs will share the same y value at their endpoints, and they also must share the same slope at their endpoints. So we got to create the scenario that's needed in order to solve for A and B. We're looking for two unknown constants. So that's why we need two separate equations, so that the two equations can kind of help each other out and solve for one variable and then the other. So let's talk about the continuity piece. So if the function is continuous, we can set the equations equal, because they must share the same y value at x equals 1. So I'm just simply going to set the top expression to the bottom expression, because they're going to have to agree at that x value. So what do you think I can replace every x with? 1, yeah. You're not going to be able to solve all the way because you have two missing constants. So the best you can do is just combine like terms and then wait for the other equation to give you more information. So it doesn't really matter how you combine it. Just reduce it to as far as you can go, and then we can come back to it later. Okay, any questions here? So the differentiable portion means that they must share the same slope. So that means we can set, guess what, we can set equal to each other as well.
The slopes.
Okay. What's another word for slope? We can set the derivatives. Yeah. So this is where calculus comes in. Now, all we need is power rule, but the A's and B's throw students off. Okay. So the way you want to think of A's and B's, that those are unknown constants. So however you treat 3s and 4s or 2s and 3s is how you want to treat A's and B's. So let's find f prime, and then we can set the two parts equal. What's the derivative of ax plus, well, first off, what's the derivative of ax? Just a. A lot of students say x, but it's just a, right? So pretend like that's 3x, right? 3x will become 3, so it should make sense that ax becomes a. And then 3 goes to what? 0. So that's the first piecewise there. That's my derivative for my top part. Okay. Bottom part, 3x squared plus x plus b. Let's do each one here. 3x squared becomes, okay, good. X becomes, okay, good, goes to 0. B doesn't stay as b. B doesn't go to 1. B goes to 0. So we get 6x plus 1. X is greater than. Are we good so far? Okay, set both equal to each other. What can I replace x with? 1. Yeah. So this is nice because we can just have A already solved. And now I can use this to plug in and solve for the other one. B equals what? 6. These are the biggest trouble students have is with the derivative. And so after we get through number 3, we will go back and maybe I'll create some more equations just for us to practice finding the derivative. Because I think students, for the most part, are able to, like, I think, you know, once you see enough of this, we know the setup. It's always set the equations equal, set the derivatives equal, and then plug in x with whatever number they give you. But then the trouble that students have is just getting to that derivative involving a's and b's, and then that throws off their entire answer. And sometimes problems may not even say the word continuous. They'll just say that it's differentiable. But the reason that they can say that is because if it's differentiable, then it assumes continuity. So they don't have to. So it's kind of like saying something that is redundant because differentiable already includes continuity. But I think it's good for us to say continuous and differentiable so we can see that, okay, there are two different components. There are two separate equations, one dealing with the equations equal to each other and the other one dealing with the derivative. Okay. Do the steps make sense? Okay. Do you guys want to try number 3 on your own, just so that you can see how it feels? And then we can, then I'll create a bunch of equations just for us to practice finding the derivatives involving a's and b's. All right, let me just see what you guys have for f prime. Let's talk about each of these pieces here. 2x squared becomes 2x becomes, a becomes 0. Good. A becomes 0, 0. And this is where x is less than or equal to. All right. Second piecewise.
-2b.
Good. Negative 2b. Now, all that is a coefficient from the x. The x drops out. The linear becomes a constant. And the 1 goes to. 1 goes to. Plus 1 becomes what?
0.
0. Okay. All right. So now it should be pretty straightforward, right? You're replacing all the x's with 1s. Set these equal. Replace all the x's with 1s. And then see what you have, right? Solve for the constant that's easier to solve, and then plug into the other equation to solve for the other missing constant.
Any of those problems that we had when we first started learning?
Limit definition? No, I won't put those on.
Those be on the exam?
They're going to be on the AP exam in the sense of you're not asked to find the derivative. You're just if you see that notation, just know that they're asking for the derivative of some function, and then use the derivative rules that we know, and just use that as notation to find the derivative. That's all. They're not going to be expecting you to find the derivative using limit definition. They just have to recognize, oh, that just means find the derivative. Yeah. Okay. How do we feel about this? Okay. Can you guys go to the very back page? There's a blank page, and I just want to write down a bunch of functions and just ask you to find a derivative and just see if you're comfortable with all these a's and b's involved. All right, let's talk through this and check our answers here. 2ax squared becomes x. BCX, CD,
Zero.
good, 0.
Zero.
All right, bx squared
2bx.
minus
2.
0, 0. Okay. All right, cax squared
2bx.
cax minus
8ax.
good
0.
0. Okay. Yeah, so that's the biggest trouble spot students experience on this problem is not knowing what to do with the b or a and b, or calling this derivative x instead of bc. So, but hopefully you guys feel okay with. I think that's the hardest part. Once you get past the derivative, then you're setting equations equal, derivatives equal, and you're just solving for the missing constants. Okay, all right, but we'll definitely do some more practice before the test. All right, let's look at page 20.
You're gonna get like a review guide packet.
Okay, so yeah, let me talk about that. So you're today and tomorrow, we're just gonna go through this review packet. And the full test review, I have it in the back of this packet here. So if you look at page 30 to 32, this is a really good representation of what your test will look like. So I'm going to save this page for Wednesday morning for the morning test review, but hopefully you guys can use this as your mock test on Tuesday night. And if you still have questions, you can have me walk through it with you Wednesday morning. So, yeah, you can get through page 30 to 32, and you feel comfortable with it by Tuesday night, you should feel good for Wednesday test, or if you want to work it earlier. But I include a bunch of reviews before that, but 30 to 32 is, I think, is where we're working towards. That's going to be your best representation of your test.
I'm
Yeah.
sorry, is that one 7:15 or 7:30?
7:15. Yeah.
Thanks.
Yeah, I'll make Wednesday something. It's going to take a little bit longer, so I'll start the review session earlier. But I did record this session from last year. So if you're working through a Tuesday and you need a video to watch, I'll have that video available from last year. You can just click on it, and then that. But I'll also create a new one Wednesday morning. Okay, so that's what we're working towards. All right, so let's go to page 21. 20, sorry, 20. All right, number 1. The average rate of change of 4x minus x squared on the interval is, so average rate of change, what's our strategy here?
And one,
Just find what?
it's just f of 3.
Just slope, yeah. So just f of b minus f of a over b minus a. There's no calculus here. We're just doing change in y over change in x. Okay, and again, you get to use a calculator on Wednesday's test. Number 2, the instantaneous rate of change at the endpoints are, now we can involve what? Derivative, yeah. Instantaneous means it's a moment in time at a very specific point on the curve. Now we want to find the slope at a point, and so that's requiring derivative. So we'll find the derivative, f prime, and then we'll find f prime of 1, we'll find f prime of 3. So we're going to expect 2 answers for number 2. Okay, so f prime of x is 4 minus 2x. Plug 1 into the derivative, I get slope of 2. Plug 3 into the derivative, I get a slope of -2. So I have 2 different slopes at different endpoints. Number 3, what does that notation mean? d2y over dx2. No. Yeah, it just means second derivative. It could mean implicit depending on what the equation looks like, but it just means find the second derivative. I think for now, let's just do the first derivative. The second derivative requires a little bit more. Maybe we'll come back, revisit it, but I have a specific problem for that later. But let's just find the derivative. Let's just find dy dx. Okay, let's not worry about the second derivative for now. So number 3, we're just finding the derivative, but to get ready for the derivative, what should we do? Yeah, rewrite it as what?
X squared plus 1 to the 1.
To the 1/2. Okay, we need to be able to recognize this. What process is needed to find this derivative? This is chain. Yeah, this is outside, inside. We'll just stop at y prime for now. Right, so these are being all multiplied, divided, so we can all kind of merge it all together. So I see 1/2 and 2, which means I can turn that into what?
X.
Yeah, just x, right? And that x, well, that 1/2 and 2 cancels out. There's an x that's in the numerator. And then the negative 1/2 indicates I'm going to push that to the denominator. So I have numerator over denominator. All right, number 4, if the line tangent to the graph of the function at the point 1,7 passes through the point -2, -2, then f prime of 1 is equal to. Now, we don't know what the graph looks like, but we do know that the graph is tangent to the line that's going to pass through these 2 points. So let me just draw a real quick version so that you can kind of see it. So let's say I had a graph here at 1,7 and 2, -2. Sorry, -2, -2. Okay, and let's say the graph looks something like this. This may not be what the graph looks like, but we do know that the graph is going to be tangent to this line. So what can we do? Even though we don't have a function to find f prime of 1, the slope of this curve at that point is the same as the slope of what? Slope of this line, right? So if I have the slope of this line, I know that the slope of this curve must also share that slope because of the word tangent. Right? That word tangent indicates that the curve and the line are going to meet at the same point, and they're going to meet at a point where they're going to share the same slope. So all we need is to find the slope between these 2 points, because whatever the slope of this line is will also represent the slope of the curve at that point. And again, the only reason that we can make that conclusion is because of that word tangent.
Will everyone like that on the test?
This is more like an AP question, but I think the important thing is, okay, if you see tangent and if you see a line, then find the slope of that line, then you have your answer, even though you know nothing about the curve, except for the fact that it's tangent. It's a good concept to know. Number 5, find A and B. So this is what we just did, right? So can you guys try this one? So there's differentiable everywhere. So we know that not only are these two graphs going to share the same y value at x equals 3, they're also going to share the same slope at x equals 3. So do what we did on the previous page, set up 2 equations, and see if you can solve for A or B, or whichever order the equation makes it easier for you to do. Yeah, I'm just most concerned with your derivative, able to find that derivative correctly. What's ax cubed's derivative?
3x.
Okay, 3ax squared. What's the root of x squared plus b? Just 2x. So if you set these equal to each other, replace all the x's with 3, you should be able to solve for a. And then set these equal to each other. Once you solve for a, plug in and then solve for b.
Says continuous.
Right. So if you don't see the word continuous, we can assume that because differential means a smooth curve. I can't have a smooth curve without being connected. So a lot of times they would leave that word out, but it's still good for us to say the words continuous and differentiable, so we can kind of remind ourselves there are 2 separate equations that we're going to need to help us do this problem. So here are my 2 derivatives set equal to each other, replacing every x with 3. That allows me to solve for a just by itself here. The other equation is going to have the b in it. Replace all the x with 3, and then afterwards I can replace all the a with 2/9, and then that should help me get to my b value. Okay, let's do a full particle motion problem here. Page 23. Sorry, 21. B is on page 23. Okay, does anybody still need? Look at this. All right, particle moves along a straight line according to S of t. This is my position function. I have a restriction with time. It's greater than or equal to 0. Find when the particle is moving left. Before we do anything with particle motion left and right, what's our strategy here? Let's create our velocity sign line. So find velocity, set velocity equal to 0. Find your critical points, test your subinterval. Let's do all that up here. That way we just have all that data that we need. On the quiz, I did see some students have a little bit of trouble when they got to this point. Some students were plugging in 0 for t instead of setting the velocity equal to 0, and then that prevented students from being able to find the critical points correctly. So make sure that if you're finding critical points, that you're not plugging 0 in for t, you're plugging 0 in for the entire v of t. Are we good with getting to the critical point, getting to the sign line, creating the sign line, filling it in, and making sure that the 1 and 3 don't get involved later on? When is the particle moving to the left?
Bracket 0, 2.
So this one is not going to be bracket. Why is that? What happens if we were to test 0? Is this particle moving at t equals 0? It's not.
Why not?
What happens when I plug 0 in for t? 0 times 2 is 0. So in this case, the velocity, the object is not moving at 0. So even though 0 is included in our domain, it is a stopping point. And because it's a stopping point, we're not going to include it in our interval. On the quiz, I think a lot of you experienced plugging 0 in, produced a positive or negative value, and that's why we included it. In this case, it's not moving because we did get confirmation that the object is stopped at t equals 0. So in this case, we'll just use parentheses. Find when the velocity is increasing. This is not talking about velocity. This is talking about what? Acceleration. So another way to think about this is talking about the slope of velocity. The slope of velocity is acceleration. So we just want to figure out when is acceleration going to be positive. what we can do is we can create an acceleration sign line and see, okay, when is acceleration going to be positive? When is acceleration equal to be negative? So set acceleration equal to 0. So power rule again, 4t minus 4. That equal to 0. Test each subinterval here. I'll test 1/2. I'll test 2. 1/2 in for t, I'll get negative. 2 in for t, I'll get positive. So when is acceleration going to be positive?
1 to
1 to infinity, yeah. So acceleration is the slope of velocity. So from 1 to infinity, because acceleration is greater than 0.
AFT equals 0. Oh, it's just set equal.
Right, we just said equal to 0.
But 0 wouldn't be one, like of the changing things for.
It's when the acceleration is changing from sign to sign, but it's different than velocity changing signs. Okay, part C, it says find when speed is decreasing. So it's not asking us it's not telling us the time value and asking if speed is increasing, decreasing. It's asking for the full interval when speed is decreasing. So speed is decreasing when what? Velocity and acceleration have what? Opposite signs. We have both our velocity and acceleration sign lines. So let's line them up and see which intervals do they show different signs. So here's my velocity sign line. Here's my acceleration sign line. So what's one interval that you see where the signs are different?
1 to 2.
Good. 1 to 2, right? This interval here, velocity is negative and acceleration is positive. Is that the only place? I think so, right? Because here the signs are the same. Here the signs are the same. It's just from 1 to 2. And the reasoning is because V of t and A of t have opposite signs. Okay, let's not worry about part D. All right, find the particle's displacement. What's the formula for displacement? S of 3, what? Minus S of 0. So it's just final position minus initial position. You just want to, it's just asking, where are you going to end up in relation to where you started? Are you going to end up to the left or to the right of where you started? And then what is that distance going to be? So you're back to where you started. So displacement is just 0. All right, next up, particles distance. We also are going to involve the starting and ending point. So we still need S of 0. We still need S of 3. But the thing with distance is that we have to basically kind of walk our path, but we only have to worry about a point in between if there's actually a change in direction. Is there a change in direction between 0 and 3 of this particle's motion? Right. Look at your previous parts here. Is there a moment in time when this particle changes directions? 2, right? Based off your velocity sign line. So we also need to figure out its position at 2. And this is a little messy here. If you plug it in to the calculator, you'll get negative 11 over 3. So I know this would feel easier. This was an integer value. Then you can kind of walk your steps, but same process here. You're walking from -1 to negative 11 over 3. If I want to figure out how much I've walked, I just subtract these numbers, right? So negative 11 third minus -1 gives me 8 thirds. So it takes me 8 third steps from here to here. And then walking from here back to -1, that's another 8 third steps. So I add the 2 accumulations and I get 16 thirds. Part D, is the velocity increasing or decreasing at t equals 2? This is not talking about velocity. This is talking about what? The acceleration, right? Or the slope. So just plug 2 into acceleration and see if you get a positive or negative value. If you get a positive value, that means my slope of velocity is increasing. If you get a negative value, then slope is decreasing. I get a 4. So basically my velocity function has a slope of 4. That means my velocity is increasing. Let's skip H here. And then I won't put limit problems on the test, so we can skip 7 and 8 as well. Okay, with our remaining time, let's see if we can do number 9 here. Find the points at which the graph of the equation has a vertical or horizontal tangent line. So before we can get to anything with vertical and horizontal tangent line, we first have to get to the what? Derivative. And to get to the derivative, what's needed here? Implicit, yeah. How many dy dx's do you expect?
2.
2. All right, so we're going to find our dy dx, and then it's asking for points, so ultimately we're going to find order pairs. But what's our strategy here? Once we get to our derivative horizontal tangent line, how do we get there?
Set the numerator.
Okay, set the numerator of the derivative equal to 0, and then find the vertical tangent line, the denominator. Okay, so but let's just find dy dx first.
Is that division sign? Or plus? That's a plus. Okay.
Oh, sorry, yeah. Some of this is grainy. Everything is either plus or minus. There's no division sign. Here, yeah, they're all plus or minus.
Is this the same problem that?
Oh, it may have. But if it is, we'll just have extra practice here. If you don't reduce, the dy dx is fine. If you have it as 8 minus 8x over 2y plus 2, that's fine as well. All right, 2y plus 4. Okay, horizontal tangent, set your numerator of your f prime equal to 0. Whether you solve for x or y, you have to put it back into the original equation to get to your ordered pairs. Okay, so once you solve for x, I got x equals 1 for the horizontal tangent. I plugged that back into the original equation, and I got two different y values. So 1, 0, and 1, -4 are the two places where there's a horizontal tangent line. And the vertical tangent, in this case, the variable that I had available to me was y. So I solved for y, I got y equals -2. Plug back into the equation, I got 0, -2, and 2, -2. So maybe the graph looks something like this, right? Where there's a horizontal tangent line at these 2 points, vertical tangent lines at these 2 points. But what if the direction says, what is the horizontal tangent line? Then we're asking for the equations of this line and this line. So the horizontal tangent lines would be what? Y equals. So basically look at the y values, right? Y equals what? 0 and y equals -4. What would the vertical tangents be? X equals 0. Okay, all right, no homework tonight. We'll continue doing our test review tomorrow.
You assign my thingy. I've seen it. You want me to find you it? I'm
Cheating.
right now.
What's your favorite way to go, Joe?
My ear package up, and then it'll take a second.
Yeah.
Well,
What's yours?
can you? Like,
Yeah.
okay. If you don't, yeah, I do. Okay.
And put some big blues.
Okay.
No, I messed up something on that problem when I turned in the quiz.
Yeah.
Well, I did something wrong. I like.
Very minor.
Good.
Ready? 3.
No, all week, nothing. I knew I messed up.
Thank you.
See you. Have a good day.
Please. You wait
Good
to,
day.
you wait. Oh, you did? Okay, thank you.
I would say you do.
It's fine. It's like